Ever wondered what makes your computer run? The answer lies within a tiny yet powerful component known as a microprocessor. This complex piece of technology, often referred to as the brain of a computer, is a marvel of modern engineering. Today, we delve into the intriguing world of microprocessors and break down their key components. At the heart of a microprocessor is the arithmetic logic unit, or ALU. The ALU is a digital circuit that performs arithmetic and logic operations, the fundamental actions of all computations. Next, we have the control unit, or CU. Think of it as the conductor of an orchestra, managing the execution of instructions, fetching them from memory, decoding them, and controlling the flow of data within the microprocessor. Registers are small, high-speed storage units that store temporary data and memory addresses. They're like the microprocessor's short-term memory, holding on to the information it needs in the moment. The clock generator provides the beat, offering timing signals to synchronize the activities of the different components within the microprocessor. The bus interface unit, or BIU, acts as the communicator, facilitating the exchange of information between the microprocessor and external devices. The instruction decoder interprets instructions fetched from memory and translates them into control signals. It's like a translator, converting one language into another. Cache memory is high-speed memory used to temporarily store frequently accessed data and instructions, speeding up processing. It's like having your favorite book right at your bedside, readily available whenever you want to read it. The data and address buses are the highways of the microprocessor, channels through which data and memory addresses are transferred. The memory management unit, or MMU, handles memory access operations, translating virtual memory addresses into physical ones. The floating point unit, or FPU, specializes in handling floating point arithmetic operations. These are complex calculations that ordinary chips would struggle with. Input-output ports provide the interfaces for connecting external devices such as keyboards, mice, displays, and storage devices to the microprocessor. The pipeline divides the execution of instructions into multiple stages, much like an assembly line, to improve throughput and performance. The interrupt controller manages requests from external devices, allowing the microprocessor to respond to events in real time. The power management unit regulates power consumption, optimizing energy use to enhance efficiency and prolong battery life in portable devices. The debugging and testing interface provides mechanisms for developers to debug and test software running on the microprocessor. Thermal sensors monitor the temperature of the microprocessor and initiate thermal management techniques to prevent overheating. Security features include encryption, decryption engines, secure boot mechanisms, and hardware-based security protocols to protect sensitive data and prevent unauthorized access. The clock multiplier adjusts the frequency of the internal clock signal to increase the processing speed of the microprocessor. The instruction cache stores frequently executed instructions to reduce the latency of instruction fetch operations. Finally, the microcode control store contains microcode instructions that define the behavior of the microprocessor and enable firmware updates. In summary, a microprocessor is a symphony of intricate components, each playing a critical role in executing instructions and performing calculations. It's a testament to human ingenuity, a key player in the digital age, and the driving force behind our computers.